Hello everyone, this is Ming Liang from North Carolina State University. So today I'm going to present our transaction paper of using deep graph adversarial neural networks to generate synthetic distribution feeders. So for the motivation for us to do this work is that nowadays the demand for realistic distribution feeders has increasing drastically. For people use them to develop and validate the DR operation and control strategies. However, for academic pupils, they usually don't have access to a large amount of such testing feeders. So we're thinking that going to build a open source system to generate realistic feeders for people to use and test their algorithms. And for the methodology we use to generate the open source test system is that we first mask the geo information of the feeder. So this is the real feeder. We first mask the geo coordinates in the real world and make them stretch as straight as possible. So after masking the geo information, so we only keep the length of each device, so how long is the cable or overhead lines, and because in a test system we only care about the electrical distance, and that is represented as the length, how long a overhead line it is, and also we may care about what's the conductor of the materials of the overhead line, because it contributes to the resistance of the feeders. And after that, we make a feeder system as a graph, a directed graph. And for each device in the system, we represent it as a node. So in a directed graph, it looks like this. They have components as A, B, C, D, E, but we make a transformation to make each component as a node. So after make the transformation, so A, B, C, D, E component as a node. So for a feeder, we can represent the relationship of a connection as the adjacency matrix A, and for the attributes like the how long material and the overhead line it is, what's the material of the conductors, we can represent it as the load attributes. We use it as a matrix X. So a graph of the feeder can be represented as the matrix of A and X. After that, we build a graphical generative adversarial neural network to generate the synthetic feeders. So for GAN, we use models and distance to optimize the goal. We have a discriminator and generator. So generator is going to generate the fake, the adjacency matrix and the attribute matrix to mimic the real world topologies and attributes of the neural network, and the discriminator is to distinguish which one is the generated one, which one is the real one. After iterations over the time, so generator will become very strong and generate the feeders that can mimic the real world one. And so that is our goal. That is we want how it look like, how it looks like in the topology and the attributes. So after that, you have the topology and attributes. We write code to and use the open source software as OpenDSS to shift back the topology and the attributes to the real runnable, executable OpenDSS files. So here is one example. So in this generated one, so here is the graph. That topology we generate one. Here is the feeder head and the load node, and also here is the capacitor. The different colors represent the voltages, and also the right one you can see is how the voltage profiles along the feeder from the distance to the feeder head. So this is our work. For more information, you can read our transaction papers for how we build the architecture of the neural networks, how we using our strategies to change back from the raw adjacent matrix to the OpenDSS files. So that's all. Thank you.